Okay, students, let us continue with the discussion where we left with the chemical bonding. Our next topic is linear combination of atomic orbitals, which is extension of MO theory. The hypothesis of MO theory is already discussed. So let us consider a molecule is formed between two atoms, A and B. So when A and B are combining, what are the possible ways their orbitals can combine? That is given by Lcao model. Lcao, the full form is linear combination of atomic orbitals. So according to Lcao, if I consider that psi A are the atomic orbitals of atom A, psi B are the atomic orbitals of atom B, then when the molecule between A and B forms, so we represent it as psi AB, it will be a combination of psi A plus minus psi B. Now, when we have plus minus, you can understand one of the orbitals formed will be with plus, another will be forming with minus. So the one which is forming with plus is called sigma or bonding MO. So psi sigma is psi A plus psi B. And this orbital will have lower energy than individually psi A and psi B. Another orbital which will be formed by subtraction, that is called sigma star or antibonding. So psi sigma star is equal to psi A minus psi B, which is formed by subtraction of the atomic orbitals. So when the electrons of the elements A and B will be filled up in the MOs, they will first go to psi sigma. After psi sigma is full, then they will go to psi sigma star. Okay, so that way their energy levels will be filled up. That we'll be discussing later. Now in your syllabus, you have to do elements from hydrogen to neon. That means atomic number 1 to atomic number 10. So how the energy levels are arranged there? You see here, for till nitrogen, hydrogen to nitrogen, we have to follow this sigma 1s followed by sigma star 1s, then sigma 2s, then sigma star 2s. This till here is actually common for all. Then comes pi to px, pi to py, then sigma to pz, then pi star to px, pi star to py, and lastly highest energy is sigma star to pz. And when it is oxygen to neon, this part gets exchanged. This part get exchanged. This and this. Okay, you can have a look. Sigma 1 is sigma 1s star, sigma 2s, sigma 2s star. Till here it is the same. Then instead of pi here we have sigma to pz, then pi to px, pi to py, then same again, pi star to px, pi star to py, and finally sigma star to pz. Now before we go to actual molecules, let us try to learn some of the terms. And the two terms which will be coming across quite often here is, one is called paramagnetic substance and diamagnetic substance. So as the name suggests, you can understand these are something to do with magnetic behavior of a substance. Now you know all elements, they are made up of electrons, and electrons, they have their own spin, they are revolving around the nucleus, so they produce their own magnetic field. Now, if I have a horseshoe shaped magnet, okay, the specialty of horseshoe shaped magnet is the north and south pole of the magnet is facing each other within the same magnet. So, in absence of any object here, if we have only air, then the lines of force originate from north and go to south, parallel to each other. So there will be we can count, suppose, the number of lines of force. So there will be certain number of lines of force within this area. Now if I place a substance here, two things may happen. One thing may happen that the lines of force, they are not able to pass through this. They get repelled by the substance, and the number of lines of force per unit area decreases. In that case, such a substance is called diamagnetic substance. That means they don't allow the lines of force to pass through them, magnetic lines of force to pass through them. So the reason when it was studied that why certain substances, they are diamagnetic, it has been found that If a molecule is having all the electrons paired, no unpaired electron, then such substances behave as diamagnetic substances. Then, if we take another situation where we find the moment we place the substance here, more and more number of lines of force are trying to pass through this area. So number of lines of force increases. Such substances are known as paramagnetic substances. Okay, paramagnetic substances, and the cause of paramagnetism is found to be presence of unpaired electrons. More the number of unpaired electrons in a molecule, more will be the paramagnetism. In class 12 also, you will be requiring this part when you will do D block elements, and sir will be taking that part. So you should look confident when you hear these terms. Okay. So in this way, we come to the actual molecules. Suppose our first molecule is H2. How H2 is forming according to MO theory. Now, hydrogen atom, you see here I have not written H2, I have written H. Hydrogen atom has one electron, so electronic configuration is 1s1. How we represent this in the MO diagram? You see, I draw two parallel lines and here I write energy. That means these parallel lines indicate energy axis. Then here I write AO of H, that means atomic orbital of H. This way also I write AO of H. So these are the two hydrogen atoms which are present in the molecule. And at the center we write MO of H2, that means molecular orbital of hydrogen molecule. So please be careful, here you write H, here you write H, and here you write H2. So here we have 1s and here we have 1s as shown in the electronic configuration. And how many electrons are there in each of the atomic orbitals? Just one. So we place one electron here. Now we know in the previous module we have seen that when two atomic orbitals combine, two molecular orbitals form. One is lower in energy, that is sigma 1s, another is higher in energy, that is sigma star 1s. So what happens here? Altogether, how many electrons I need to distribute in the MOs? Here you see I have one here, I have one here. That means altogether two I need to distribute. So where the two will go? The two will go in the sigma 1s because each orbital has the capacity to hold two electrons. So here both the electrons go to sigma 1s and sigma 1s star remain empty. Then how we write the MO configuration? As we write electronic configuration, here we write MO configuration. So MO configuration we can check from the figure. It is sigma 1s2. So I have written here sigma 1s2. Your next job is to calculate bond order. Now what is the meaning of bond order? Bond order is the number of bonds in between the two atoms. So how we calculate bond order? Bond order is half of number of electrons in the bonding MO minus number of electrons in the anti-bonding MO, and we represent it as Nb minus Na, so which is equal to half of Nb minus Na. Now how many electrons I have in the bonding MO? 2. How many I have in the anti-bonding MO? 0. So we write half of 2 minus 0, that is 1. So we all know that between two hydrogen atoms there is one bond. So bond order in hydrogen molecule is 1. Now the question is, what will be the magnetic behavior of hydrogen? That means if I place hydrogen in the magnetic field, should it be attracting the magnetic lines of force or should it be repelling the lines of force? As you can see here, the nature of the electrons out here are all paired. That means it will show diamagnetic behavior. That means the lines of force will be repelled by hydrogen. It will not be attracted by hydrogen. So the diagram is not very difficult. You need little practice. Okay. Then next we move to helium. Helium 2. So to begin with, we begin with helium atom. So helium atom has two electrons. So its electronic configuration is 1s2. So we understand helium has 1s orbital and it has two electrons in 1s orbital. So we draw the same thing. We draw two parallel lines. We label E. We write AO of helium on both sides. and at the center we write MO of He2. Then we draw sigma 1s, sigma 1s star, and we distribute the electrons in the atomic orbitals first. Since helium has 2 electrons, so here we have 2 electrons, here also we have 2 electrons. That means altogether we have 4 electrons to distribute in the MOs. So it will be sigma 1s2, then sigma star 1s2. So you see I have written the configuration sigma 1s2, sigma star 1s2. Make sure that the 2 electrons have opposite spin. Then we calculate the bond order. So bond order will be half of Nv minus Na. So here, since both the orbitals have 2 electrons, so half of 2 minus 2 is 0. That means when bond order is coming to be 0, you understand that the particular molecule does not exist. That means helium-2 doesn't exist. Now, since the molecule doesn't exist, no question of magnetic behavior. So we'll take up the next molecules in the next video. Thank you.